Good afternoon, Hardeep sir.
Good afternoon, Saurav, and good afternoon, everybody who's present.
We'll wait for a couple of more minutes as we have most of them to join. Thanks to all the participants who have joined on time. So let's wait for a couple of more minutes and then we'll start the session. We'll start by 3:05. We'll wait for more, a couple of more minutes. We'll start. Sincere thanks to all the participants who have joined. Anand sir, Ishan, Goel sir, James sir, Saurabh sir, and Sunil, Kapila sir, Kapil sir. Currently, you all have been muted. We'll allow you to unmute yourself once we are done with the session and the session is open for question and answer. Currently, should we start, sir? Ardeep sir, we
Yes, anytime
yeah
you feel appropriate.
yeah. So because it's already 3 past 2, so let's wait for 1 minute and then we'll start. Cause that's not
Yep.
think the participants who have joined. Fine, so we'll start. You are able to hear me, right, everyone?
Yes, I can hear you, and the other people probably are on mute, so they can't tell you.
Okay, yeah. Good afternoon, everyone. A very warm welcome to you all for today's webinar on energy from waste. We are really glad to have you all with us, and it's quite motivating to see so many professionals from different backgrounds coming together to learn and share ideas on such an important and a relevant topic in this scenario. Thank you for joining us, and we hope you find the session successful and very engaging. I am Saurabh Purtarkar and I'm managing training operations for Quality Austria. To give a brief about Quality Austria, we have completed a decade delivering the quality services with a workforce of around 3,200 employees and a strong client base of 2,100. Also, with 26 offices across India, QACA is a leading service provider in certification, testing, inspection, training, cybersecurity, and sustainability. We hold multiple accreditations, which include NABCB, QCI, IRCA, and 17020. Additionally, we have our own labs for code testing, material testing, and cyber lab. So before we proceed, I just have few quick notes for all the participants. The webinar will run for approximate 1 hour, including the time for question and answer. If you have any questions, we request you to put in the chat, or we have created a separate tab for Q&A, so you can post your questions there and we'll address them at the end of the session. Currently, you all won't be able to unmute yourselves. We will be allowing you to unmute at the end of the session once the session is open for Q&A. We'll kindly request all the participants to on their cameras currently because that would help to have a more engaging environment for the trainer as well. So this session is recorded. So in case you want to access this session again, you can visit our website. So you will be able to access the session, the webinar from there. So even you can access our earlier webinars also. So we have uploaded all our webinars conducted until now on our website. So you will be able to access. So now it's my pleasure to introduce our faculty for today, Mr. Hardeep Grewal. He's a Chief Sustainability Officer at QACA and an expert in sustainability and climate change. Grewal sir has a strong educational background in agriculture and engineering and holds a master degree in technology from IIT Kharagpur. He has worked in many areas from right from community level work to policy research and technical writing. So thereby giving him well-round of view of all environmental issues. He's passionate about moving towards clean energy and helping communities and organizations find smarter ways to deal with the impact of climate change. His deep knowledge of science, policy, and practical solutions make him a valuable guide for anyone working towards a greener future. So we are lucky to have him today with us. Please join me in welcoming Hardeep sir. Good afternoon, Hardeep sir.
Good afternoon, Saurav. Thanks for the nice introduction.
just before we start, participants, I would like to have we have created a poll, so I would like to all the request all the participants to just answer those polls. I'll just open those now. Just give me a moment. So once you're able to see it, you can just let me know. Is the poll visible now on the chat? You can check. Anyone can confirm. Sir, in the chat we are able to see. Yeah, I think so. In the
It's
chat you
visible
can
on the
check.
screen, but it's visible on the screen, but how do? Yes, it's visible there.
You can just take few minutes. There are three poll questions, so we'd request you.
No, I don't think
Uh,
people can access it. It's visible there. Could you just unmute the participants so that they can speak out for a short while? I mean, I
just
certainly
hold on. Just hold on. Let me check.
people cannot respond to the poll. That's the problem. It's
Okay.
visible on the screen.
Fine. Let me check into it. In the meantime, sir, we can start. I'll just let you know once it's ready so that we can have it then.
So then I go ahead with what I'm supposed to be doing.
Yes, sir.
Okay, so I'll share my screen. Believe that I'm on to the next, the opening slide.
Yeah, on the first page, rubbish to wealth, we can see.
Great. So I just tweaked the title of this thing a bit so as to make it more communicative. Otherwise, we're talking about the same thing that we were. What I'll do is I just organized it sequentially in 5 sort of small parts. One is that it just gives you an overview in the beginning of how much waste there's in the world and then how much waste there is in India. And also an understanding, small short understanding of what are the different kinds of waste that there in India. Then we get into the question that with the volume and the kind of waste that is there in India, what happens to all this waste? After having investigated this, we take a look at some of the technologies that are currently commercially viable technologies and that can be used. It's not specific technology, it's categories of technologies that I'll be dealing with, and I'll be dealing with 5 of them. And at the end of the session, I'll speak a bit about how we can go about engaging those technologies and what we should be doing to do that. So that would be the sequential order of things that I'll be sharing with you today. And to kick things off, let's start here. This is the first slide, and 2 billion tons of waste each year does not communicate very much to me, and I don't think it would be communicating very much to you. It's just that when I started looking at this abstract figure in a more concrete way, so to make it more communicative, I've just put this picture over there. It's nothing but containers that you very commonly see loaded on trucks that are going across the country, or you see them on ports. So if you were to start filling up these containers one after another with all the waste that gets generated each year, and then you put these containers with their long ends across touching each other, you could actually make a string of these containers right up to the moon. So that's the huge volume of waste that gets generated. The World Bank did a study and it said that the conclusion was that because the levels of income at the disposal of people are rising in a general way across the world, and because habits are changing in a manner in which more and more waste is being generated, the rate of the whole thing just doubles the progression of the population itself. So the waste is increasing at twice the rate of the population. So that's a lot of waste across the world. The good news about it is that a portion of this does get eaten up by nature in a way that nature has been doing for millions and millions of years. So nature takes care of a good part of our waste, say the organic waste that is there. But if we humans are piling up a lot of inorganic waste, and nature really doesn't have many ways of handling that. The smaller part of the story, but still the good part of the story, is that there are countries, organizations, and people active in doing something about waste, handling waste, managing waste, and therefore there is considerable interest across the world in managing waste, reducing it, and also um, doing something productive out of waste. Now, presuming that when we began this thing, we had in mind an audience that would primarily be made up of people interested in business. So the question before any person engaged in business is that, is there any money in the whole thing? Because if there's money, business people tend to be interested in understanding things in a more concrete way. And if they understand that there's no money in the whole thing, then their interest shifts and starts treating it as an academic subject, which they obviously would want to know about it some point of time. But then it's a different kind of interest altogether. So the answer to that short question is yes, a lot of money can be made by processing waste. One big reason is that it's a resource that's almost free. It's waste is lying all around us. It just needs to be collected. There are no huge royalties associated with waste. There are no upfront money that has to be spent in buying waste. And even if there has to be money that's to be spent in buying waste, it's still a small amount of money, and the word actually means what it is. So I'll be primarily saying two things. One, energy can be extracted from waste, and energy can actually be extracted from most kinds of waste. It's not a futuristic thing because the technologies to do that in a state of preparation, and a lot of them are commercially viable technologies. This is something that we'll be speaking in much more detail. The other thing that is associated with waste is that many times in many technologies, apart from the energy that you pull out of the waste, you also end up with co-products which have a higher value compared to what happens when it's not, it's just led to do what nature does to it. So I'm taking a particular case of fertilizers just to clear up the pitch. If you were to look at this slide, on the bottom right hand corner, what I have is a diagram of a very common biogas digester. It's a very simple kind of a thing with inlet pipe where you put in the kind of things that are shown on the top of the screen. It enters the digester, and it's microbes that work on the waste. In the process, they generate biogas, which is a mix of methane, carbon dioxide, hydrogen sulfide, ammonia, and some water vapor, roughly in the proportions that I've written on the screen. To the right, we have a digestate where after the biogas comes out of the thing, the whatever is on the top of the pit moves into this digestate tank. Now this, say if you were to take cow dung and you were to put cow dung into the inlet pipe, the digestate that you get is a better fertilizer for your fields than the cow dung itself, even if it were left to compost in a natural way on its own, or it were left to, it was a better thing was done that there was some kind of composting done to it. Even in that situation, the digestate that you get out here from this plant is better fertilizer for your feeds. So that's the initial point that I was making, that apart from the energy that can be derived from waste, many of the co-products that come out of waste are also things of value. This applies to other things that we will think up when we move along the webinar. So this digester that you get is particularly rich in phosphorus and potassium compared to the compost. Now you compare this to a situation where either it's just let to rot on its own and nature takes care of it as organic trash, or what happens in a country like India is that the cow dung is collected and it's converted into cakes, and then those cakes are burnt. So those would be the worst solutions. This is a good solution in the sense that it gives us biogas, which is a form of energy that can be used to turn turbines and make electricity, or burned directly as cooking fuel, or used in automobiles, and lots of things can be done with the biogas that's there. The digestate is a co-product of higher value than what goes into the inlet, or even if it was processed in some way by nature or by human beings in other forms. So waste lying around is not all that bad, and there is considerable wealth that can be generated out of waste if we have the knack for doing things, and if we sort of invest time and energy and some amount of research into doing what we would like to do. So in the first slide, I talked about how much waste there is in the world. I would try to be more specific over here. This is a table that's been constructed by putting in information from all kinds of sources, primarily Government of India sources. One of the problems is that we do not have a very robust data collection infrastructure when we start speaking of waste. But these are good estimates for us to work our way around. The biggest entity out here is agricultural waste, which is 683 million metric tons. And the other point of interest is municipal solid waste that you have in the top, which is about 66 million metric tons. Plastic waste below that is actually a component of municipal solid waste. I've just put it here as a different entity because people understand that old plastics can be shred up into small bits, and then sort of pellets can be made out of it, and then the whole plastic can be recycled. So there is a particular significant interest in plastic waste, segregating it out of the mountains of waste that we have and then doing something to it. So I've put it as a special category. Otherwise, it makes up part of the municipal solid waste. Okay. For perspective, let's just get back to the digester that I was showing you earlier on, and say that we looking at a micro-sized biogas plant. All you need is about 40 to 50 kg of cattle dung for that, or you could have other kinds of agricultural waste that could be used. If somebody is interested in a bit more perspective, if you have a cow or a buffalo, you are looking at somewhere between 10 to 15 kg of cow dung a day. So if you have, if there are two families that are sharing a small biogas plant and they each have two buffaloes each, this is a working model. So cow dung itself translates into a lot of waste. India, as I said, has about 680 million metric tons of agricultural waste, bio-waste. This includes cow dung and all kinds of other agricultural residue. If we were to just use this in the most conventional kind of biogas plant, we could actually have somewhere between 4 and 4.5 family-sized biogas plants in the country, just using up this volume of waste that we have, agricultural waste over here. And then there's another entity that I spoke of, that's the 65 million metric tons of municipal solid waste. So we have a large amount of this resource lying around us. Now let's just take a look at what the country is currently doing with all this waste that I'm showing in this table. So that's a picture which tells you what happens to this waste. Let's start at the top. WTE generation, which I shows as 0% in this thing. It's not actually 0%, but we are using a tiny fraction of that enormous amount of waste to generate energy. A good portion of it, say about a one-fifth of that, is going as landfill. Yes, since we are a poor country and there are a lot of human beings involved in managing waste in the country as a voluntary, self-driven, solo activity, um, but organized beyond that, beyond the picking up, and then it gets recycled. And this is something that is credible in the sense that we all that waste is not getting piled up. But it's unfortunate that it's poverty that's driving this whole business. Otherwise, those people who are engaged in this activity would be doing something else if they get a chance to do it. There are other things that happen to the agricultural waste. One thing is it's piled up in our country in villages. In northern India, the word that's used for it is rudi, where you pile up waste in a pile and you just wait for nature to work on it and convert it into compost. Agricultural waste is used as feed for cattle as well, and it's used as a fuel where it's used for cooking purposes. And then there's a whole volume of waste that is just mismanaged. It's waste that's burned, it's uncollected, municipal solid waste, plastics, e-waste. So that completes the pie. Of interest to us is what I'm showing at the top of this list. We are actually doing very little to generate energy from waste in a modern scientific way. And we should be doing that. So the scope for what we want to do is enormous. It's just a question of industry stepping into this space and, as I said, helping the country in the first place and also making money in the process. This is a picture of a landfill, and I am talking of waste to energy, where the information on this slide is about waste to energy plants that involve burning of waste. Incinerating is burning of waste. So the information at my desk is that we have had about 14 plants installed in the country at various points of time. As of now, only 7 of them are functional and 7 of them are not. And the reason that is cited is that most of the technologies were imported from outside. The waste in countries from which the technology was imported is of a different kind compared to India's waste. And therefore, the technologies, the plants that were set up could not function. So that's an answer to a question that's posed. It's a correct answer, but it's not a very satisfactory answer because a lot can be done once you come to that kind of an understanding, which is not at all incorrect. It's correct. Just take a look at this. If this waste that I'm showing in this slide doesn't burn inside plants that are imported, this is something that's happening on its own. These are fires visible in this picture that I'm showing you, spontaneous on their own. So the waste burns. You can't say that the waste doesn't burn. It does burn. The whole question is getting it burning inside a controlled environment in which we can tap the energy. So the whole thing is that, yes, it's true that Indian waste is of a different character compared to the design, the way those plants were designed for the kind of waste those plants were designed. So we have to work our way around the problem. So let's start understanding the peculiarities of India's waste, which distinguishes it from, at least from the waste in developed countries, from where most of those technologies were imported at some points of time. First point is that municipal solid waste in India, apart from agricultural waste, is also very highly organic in its character. It's biodegradable and therefore it doesn't match the incineration processes that were there. It's high on the moisture. It has low calorific value, which would be about, say, two-thirds of what you would get in developed countries, or even half of what you would get in developed countries, or even less than that. But it is waste that has a lot of organic content. It is waste that has a lot of moisture in it, and it is waste that when you burn, you do not get as much energy from a kilogram of waste as you would get in a developed country. And the last point is, despite all the human activity that I was talking of, 90% of India's municipal solid waste still remains unsegregated, despite human beings picking up the plastic out of it or picking up certain metallic objects out of that waste. So it contains a lot of things that I've mentioned over here: organic matter, recyclables, many inert materials, hazardous substances. So the question before us is that we as a country need to work a way around this issue. We need to understand the peculiarities of Indian waste and then go about utilizing our waste with suitable technologies. So we're being challenged to innovate. We cannot just copy and borrow. Let's look at the scale of things. We have somewhere around 660,000 villages and we have about 8,000 towns. Each of them is a site for waste to energy technologies to be implanted and to be contributing to the national energy pool. And also, each of them is a site for enriched use of waste for reduction in the waste all around. Current practices of utilization of agricultural waste are very low efficiency ways. We just make cow dungs, or we let agricultural waste compost on its own and not give us any energy and give us fertilizer that is of not very high quality, that is actually of low quality. Municipal solid waste is a sad story, an eyesore. It's piled up in the best cities that you have. I, sitting in the national capital region, have three huge piles of municipal solid waste around this big city. One is Balaswa, one is Ghazipur, and the third is Okla. And these are huge mountains. So as I said, the wheel actually doesn't need to be invented. I mean, we have numerous technologies, and we have viable technologies in various parts of the world that can be used for whatever we need to do. So we need to adapt and innovate. Okay, now I'm going to walk you through 5 different technologies that we can use. For perspective, the picture on the bottom right-hand corner is the world's largest waste to energy plant that is coming up in a country which happens to be our next door neighbor. It's coming up in Shenzhen in China. And the blue roof that you see on this mammoth structure is actually all solar panels. So the sunlight falling on the roof gets converted into electrical energy, and the city of Shenzhen is going to benefit by having more than 1/3 of its waste going into this, producing energy. And also, what comes out of this plant is going to be high value stuff that farmers are going to use. Indian agriculture can do a lot of similar things. As of now, we have about 4.2 to 4.5 million micro anaerobic digesters that I was showing you, and we also have bigger digesters, but there's a lot that we can do using this because this has been a technology that's been successfully deployed in our country, and it just needs to be scaled up. So the proof of the concept is that we actually have so many of these digesters already installed in various parts of the country, including in rural households. Okay, this is a step up from where we were, because in this case, you get methane, which is what the biogas, the portion of the biogas that we are primarily interested in. Say about half to three-fourths of the biogas coming out of this would be methane. You would want to enrich this thing. So there are ways in which that methane can be, the biogas that's coming out can be enriched. You get rid of the carbon dioxide and the hydrogen sulfide, and you can achieve methane that can be put into the grid that I'm showing you on the top right hand corner. And that is the kind of thing that can be done. There are people who are doing it primarily in Europe, and what is being done in Europe can be replicated in India by tweaking the technology. Because as I said, we just cannot copy and paste. That doesn't work for us. Okay, this is the third kind of thing that can be done. That you burn the waste. You burn the waste and you burn it. All the information that I've written out here is just information about the technology you can be done. There are various kinds of technologies that get into this category, but you burn the waste, you use the heat in order to do whatever you would like to do. People primarily think in terms of generating electricity from the heat, which is a pretty good idea because it can be transported to all parts, needs to be used up in a cheap and efficient way. And a lot of countries are doing this kind of a thing, but our emphasis should not be on this thing. I'm not saying that we shouldn't be doing it. We should be doing it in significant amounts, but our emphasis should not be on this because of the character of our waste. We should be focusing on technologies that are appropriate for the peculiarities of our waste. This is another thing that is worrying because every year in winter especially, there's a lot of hue and cry about farmers burning the crop residue in their fields itself in order to get rid of it. So what I'm showing you is a plant in Sangrur in Punjab. It's the yard. This is from a yard of that plant where you have these bales of rice stock piled up over here to be used in this huge plant that's being done to generate biogas. It's been put up and it's been recently commissioned about 2 years back. So gasification is another technology that is suitable for India. Before I move on to the fifth technology, let me just give a shout out to one thing, that there's this International Energy Agency, and it has done a good activity in the sense that it has surveyed all the kind of waste to energy technologies in the world and it has graded them. So grade 1 is just where we're thinking about things and you're doing small laboratory experiments with it. And grade 11 is something that is applicable in large portions of the world. So as you move up the ladder, you move from the lab to commercial settings. So technologies at level 9, level 10 and level 11 in the International Energy Agency scaling system are commercially viable technologies, and all four that I've shown you earlier fall into that category of technologies at level 9 to level 11. Pyrolysis, which I'm showing you over here, is again a technology which is at that level, 9 to 11 level. The great thing about pyrolysis is that apart from the energy that you get, you also get biochar, which is something similar to charcoal, lakdi ka koila, which we call. It's not exactly charcoal, but it can be crushed and spread in the fields where it works like a very good fertilizer. And the other great thing about it is that it is something that is carbon sequestering, in the sense that biochar stays for a long while with the carbon in it, and it doesn't release that carbon into the atmosphere. So pyrolysis is a very climate friendly technology. Having said these great things about all these five technologies, I still would want to say many things about how we need to go about it. But let's just make a short list of what we should not be doing. There's a common complaint that the Indian population doesn't know how to behave, and we don't know how to segregate our waste and put them in different kinds of baskets, and therefore nothing can be done about this thing. Okay, from a cultural point of view, it's nice to say that, but from an engineering point of view, we really cannot say that. Engineers are supposed to make do with the input that they're getting. So we have to refine the technology for that, and we cannot complain that since the Indian population does not segregate the waste, we cannot do anything about it. So we cannot be lazy engineers. We have to work our way around that. The other thing that's commonly done is that if there's waste piled up around a city, there's a lot of disturbing noises that people make for the municipal corporation. So the municipal corporation one day sits down and then decides to put some topsoil from other places on this huge mountain of landfill. And then once the soil is there, then they plant trees, and they say, oh, we've converted all that into a beautiful mountain, and now the city looks very beautiful. The problem with that is that the entire landfill is still leaching hazardous substances into the earth, and it's still leaking fumes into the atmosphere. So you've actually not done anything meaningful about it. You've just beautified the place. So we should not be looking at cosmetic schemes. The third thing, that the point that I want to make is that there's another line of argument that, oh, we are a good culture. We generate very little waste compared to other countries. So we need to be actually patting ourselves on our back. And this is not one of national worries. No, it is our national worry. The government has launched a scheme like something like the Swachh Bharat Abhiyan. So it is a national worry. Waste is a national worry for us. And even if it's good that we have a low per capita waste generation culture in our country, but that doesn't mean that we shouldn't be doing anything about whatever waste we are generating. So we need to get down to it. And in an absolute sense, India is a big place for waste. It's huge. The size of the country is huge, and the volume of waste that is piled up and not treated in any manner is also huge. So to accept the challenge, and we need to understand that we would probably be needing somewhere around 1 crore micro, small, and medium scale waste to energy plants in order to get rid of all the waste that accumulates each year, and to reduce the volume of waste that has been piled up. So this is a huge thing that needs to be done, should be done, and can be done. What do we need? The first thing that we need to be very smart on is that we need to understand each waste catchment, analyze the character of the waste in that, do laboratory testing if that be required, and then choose an appropriate technology from the hundreds of technologies that are available. So that is the starting point of the whole exercise for each waste catchment, whether it's 3 waste catchments in a village or it is 200 waste catchments in a small town. Each waste catchment has to be analyzed for its specific waste. It may seem big, but it's not something very complicated, and it's all it requires is effort for about a few man days. Once an appropriate technology has been selected, the exercise should not stop at that. Some engineering, some innovation needs to be done further to make the whole the design of this thing, the waste treatment plant that we're doing, more appropriate and more efficient. The last thing is that in a lot of situations, it will not be a single technology that will provide the best solution. It may be a combination of technologies For example, stage one could be a digester, and stage two could be an incineration plant. There could be other combinations that need to be worked out. What I think we need to do as a country in terms of the policy that we need to adopt for this whole thing would be that we are very specific about what we are doing, and it should not be replicated. Technologies should not be repeated in adjoining villages or even in adjoining waste catchments. We need to be very specific. So, if I were to think of a slogan, we actually need a unique solution for each waste catchment. And if we were to do that, we would be well placed as a nation and doing something for the remaining part of this century and getting rid of our waste, and in the process, building a developed country as everybody desires over here. So that concludes what I wanted to speak for myself, and I would now hand over the floor to your questions. I stopped sharing my screen, so I'm just looking forward to your questions. Please unmute yourselves.
Yes, participants, Saurabh here. So I have allowed you to unmute yourself. So you can now please unmute and ask your questions, or even you can put them on the chat or the poll questions. So please, anyone, please, any questions? Otherwise, we had a few questions which were initially shared by a few registered participants. I'll move to them, but we'll first take the questions from the ones who are there on in the session right now.
So, Saurav, I
Right.
don't think anybody's asking a question. So,
So I'll
you
just
could.
start with that. So maybe I'll check. We'll come back to them later on. So currently, there's one question asked by Mr. Prajwal. So he wanted to know India's government has already initiated Swachh Bharat Abhiyan. Isn't that a step in the right direction? Is what he's asking.
Oh yes, it's definitely a step in the right direction because it aims at cleaning up the country from its waste. It has done significant things. For example, if you were to remember the pre-Swachh Bharat Abhiyan period, the railway tracks were a filthy mess, including the premises of the railway stations themselves. And now you find that the trains actually have toilets where the waste is not the waste doesn't fall on the railway tracks. Significant amount of villages also have toilets, and so a lot is being done in this direction, and this has been a very good drive. The evidence is there in front of everybody. More than that, if we are to talk of waste to energy technologies, the government, through its Swachh Bharat Abhiyan, the Swachh Bharat Abhiyan has many components: a urban component, a rural component, so on and so forth. And it's in the mission mode, so it's tied up with a lot of ministries and departments, and it offers you money if you were to indulge in waste to energy technologies as money that can be used up to set up a plant, to engage in research. So the government has schemes. So Swachh Bharat Abhiyan, in my opinion, is a step in the right direction. There's no doubt on that. Having said this, I think that we as a country need to do a lot more because, as I said, mentioned that there are 660,000 villages in the country and they're growing in numbers. There are more than 8,000 towns in the country. The scale at which waste needs to be tackled is definitely a lot more. So we need to walk the Swachh Bharat Abhiyan road, and we need to walk it with stronger steps and bigger steps. So, but I'm glad that this gentleman raised this question. Okay. Yeah, okay.
Mr. Prajwal, we have answered your question. So there's another question shared by Mr. Vikas.
There's somebody else who's unmuted the.
Yes, yes, I'll take then. Ishan sir, yes.
So I have this question that essentially waste management, because it does not directly solve a customer problem, then essentially it gets pushed back for government to do and for larger non-profit organizations to do. But are we also thinking in terms that businesses can be set up that can make active money in the process of cleaning waste in the country, or that is something that is not possible to do or not imaginable?
Ishan, I was trying to handle this question head on because This is actually what I have in mind, that if you leave it in, if you think of something as belonging, as being non-profitable, therefore it's only the government that's going to come forth and do something about it, or non-profit organizations like NGOs are going to do something about it, then I do not think that it has much of a future.
Yeah.
I think that this whole activity of waste to energy has a future because private enterprise businesses can make money out of it. There are certain number of reasons why businesses can, and I think they will. It's just a matter of them not actually understanding and putting their heads together to do something about it. One of the main inputs that you're going to use in the process is almost free. Not exactly free, but it's almost free. When you set up any business, that is a significant part of your costs. If you're making cars, the steel that you use is significantly there. When you get into a waste to energy venture, you can set up a plant at the site where the waste is accumulating. Land out there would also be cheap because nobody wants that land. It's filthy, it stinks. So nobody wants to live near a garbage dump, but that's where the plant can be set up. So land out there is cheap. The input itself is almost free. If not free, I mean, just involves the transportation costs and maybe the collection costs a bit. The third thing is that the technologies today, when we're speaking in 2025, are there where waste to energy plants are becoming cost efficient, which was not the case a few decades back. And therefore, waste to energy is something viable. Why it's not taken up in our country is for a very different reason that I was trying to cite. That Indian waste has its own peculiarities, and there's a challenge for industry over there that we need to innovate on what we can get from outside, or we need to design things fit in with our waste. But to answer your question, this is not something that's just there for NGOs and the government. It's something that is there to be tapped by businesses. It's something new. And when there's something new, there are chances of going wrong because it's not tested. It's not the beaten track where you will not fall because there are lots of people have walked that road. So it's new and it's there for people to try out. Yeah, thank you.
Thank you.
Thank you, sir. So there's another question from Mr. Saurabh on chat. How can public-private partnerships be restructured to mitigate the investment risk and enhance private sector participation in India's waste to energy sector?
Also, I think we are almost there. See, the government is interested. It has launched Swachh Bharat Abhiyan in the mission mode. By mission mode, the government says that we don't care about departments and ministries. This is something that needs to be done. And so the government cracks its whip and says that all departments and all ministries need to collaborate because this is the mission before the country. So that is one. The other thing is that Swachh Bharat Abhiyan itself has financial components built into it. So the scope for public-private partnership exists in a rudimentary form in this mission that has already been started. But definitely it needs to be scaled up. It needs to be scaled up at a level at which you should have these 4,000 odd kind of different kinds of banks that we have in the country offering loans to anybody who comes and says that he has an idea for a waste to energy project and this is what he's going to do. So the loans should be there. The subsidy from the government side should be readily available as part of that loan. Those things need to be worked out. I think that this is just in line with the first question that somebody asked, that have we stepped onto the road? Yes, we have stepped onto the road. The scale of this whole thing needs to be made qualitatively big. That's what the challenge is. Yeah, thank you.
Okay, I hope, Saurabh, we have answered your question. I have one
I
more
would
question.
love it if I could see some more faces on the screen because
Yeah, so we have one more from Mr. Sarath. In absence of infrastructure, public throwing their waste on open land? Any rule policy to control it?
So there are large number of rules that prohibit people from doing things, and there are all kinds of rules that to my mind don't make sense. So one of the rules that I know of in certain municipal corporations is that they cannot transport wet waste. So what they do, if there are open drains and those drains get clogged, they pick out the waste from using machines and even using human labor. They pick out that waste from the open drain and just pile it next to the drain to dry. Because the rule says that you cannot pick up waste and transport wet waste. So they let it dry. Often when it's left to dry, it falls back into the drain once it's dry because the garbage truck doesn't come on that particular date to pick it up when it's dry. And the waste doesn't have a voice, so it doesn't announce when it's dry. So you have the same waste falling back into the drain and clogging. So now the rule did make sense that when wet waste is transported, it gives a lot of stink, and that's not something that you want. But then you have to work your way around. One way that you could work your way around is that you transport it at night, late into the night, between 12 o'clock and 3 o'clock in the morning, when there aren't people on the roads. So there are all sorts of rules. I don't actually find that there's a dearth of rules. There are rules that crisscross into each other, make a mess of the whole thing. Coming to the municipal authorities, they say that we have only one solution, and that is to pick up all the garbage in the city, otherwise it will lead to diseases and epidemics, and therefore we need to throw it in some place, and so we have designated places to throw the garbage, and that's what we are doing. So it doesn't matter which political party comes to power, they do the municipality keeps on just doing the same thing, and keeps on doing the same thing across the length and breadth of the country, except for a few pilot projects in places like Pune or Indore or some cities where they're trying to do something about the waste. Even in Delhi, they're trying to do something about the waste. They have 4 waste to energy incineration plants in Delhi. But though the scale of those things is very small compared to the amount of waste that is piling up. So
thank you, sir. Can I add one more thing? Actually,
Please.
I have write up the
Please.
question. Nicely you have explained. Actually, where I am residing,
Mhm.
this is the industrial area, and there is a administration offices also there, and one market is also there. So these 3 things making this locality 3 kind of people. One coming from the industrial area, they are aware about the waste and their disposal, but they don't
Yes.
find the infrastructure which is available inside the company or factory, and that is not available outside in the market or something.
Yes.
So their situation is this. Then we even myself and with my some colleagues, I approached to local administration. So rightly you said that they have only one clear agenda, that we will pick up the waste and throw to some places, designated place. What will be their end life of that waste? They are not. They are least bothered.
Yes.
They only have the area identified or given by the villager or some as per this local administration that this area is for garbage storage. Only their role is. And third one is the local villagers. Local villagers are not aware that why or where we have to keep this waste or dispose this waste, and they did even we organized some campaign from the company to raise awareness, and at that time also when we provide some infrastructure to villagers, so next day those infrastructure finish, like somebody has taken away or somebody has broken or something.
Sorry, ho gaya.
Yes, so this is also one of the challenge. Like apart from you already explained about the technology, but one challenge I feel that the difference of the awareness and availability of infrastructure to segregate the waste at source is also one of the.
Mr. Vishwakarma, let's just start thinking about what you just said, because you said some very important, interesting points. What I could understand is there is some vegetable market also, which probably gets organized on a weekly basis where you stay.
Daily basis,
Now,
sir. Daily
daily basis. Now, whatever waste is left in this vegetable market because of vegetables that could not be sold and are rotten, and the vegetable seller feels ki nobody's going to buy it tomorrow. So he leaves it just next to his stall. This waste, this vegetable waste in this market is actually the best waste for an anaerobic digester. You actually do not get a better input compared to vegetables and leftover portions of vegetables for an anaerobic digester. If things were organized in a smart way, it is one of the best things for that. Similarly, the factory that you talked of has a controlled environment. It probably does have an effluent treatment plant to treat many of its effluents. It has an organized way of handling waste within the premises of the factory. I think that if certain sensible things were done at the village level, it'll work. Earlier, we had this bigger problem of public utilities being destroyed by people who wanted to steal stuff. But this thing has come down a lot in our country, and today you have a lot of infrastructure in place in public places which remains intact, and it's not stolen or touched that way. So if you were to create a meaningful plant which actually cleans up the area, after the first 3-4 months, when people see the positive side of that, the whole culture and attitude to certain things like this changes, and that's what happens. I mean, so we do have cultural challenges, we have technological challenges, but none of them is of an order that it cannot be handled. That's all I would like to add to what you said. Thanks.
Thank you, sir.
Thank you.
So we have another question from Surya Narayan himself. How to reduce the inorganic waste and e-waste? Whether the government sets up a recycling process across the state?
So, sir, I don't think that we will actually be, as a country, reducing the inorganic waste that we are generating. We will be actually increasing that as we get more effluent, because that is the trajectory that most countries have taken. Number one. On similar lines, I do not think that we will be reducing the e-waste that we are generating. We will be generating more e-waste in years to come, because again, that is the trajectory on which the world is moving. So generation volumes are going to go up. The reduction, if it can happen, is by using the waste. And as I said, we talked primarily of municipal solid waste. One strong component of this municipal solid waste is the inorganic portion of that waste. The inorganic portion of that waste cannot be segregated manually by hand in the landfills, and we cannot expect the entire population to change its culture overnight and start segregating it at the household level and then putting it in different dustbins, and then the municipality collecting it in different pickup trucks and moving it to different places. That's unlikely to happen. So the solution has to be a solution, an engineering solution to the thing, not a cultural solution to the thing. And that probably will be a combination of 2 or 3 technologies where you pick up the municipal solid waste as it is, as a mix of inorganic substances, organic substances, and e-waste also. And then first you treat that waste for its organic content, and then you treat that residue for its inorganic content. Something of that order needs to be worked out. And this is where the best brains in the country, including those who teach in IITs and including those who work in all kinds of government bodies and private bodies, need to work out. Because, see, I mean, if Sweden can develop a technology to handle its waste, its kind of waste, so can India. India can also develop technologies to handle its own specific kind of waste. This is not asking for too much. This is something that can be handled. E-waste. Okay, let me just clear up one thing. The government actually has mechanisms and policies for handling hazardous substances. There are laws and there is infrastructure that defines how hazardous substances need to be handled. A lot of e-waste falls into that category. Number two, Once it gets accumulated in a certain place, if it's coming out of an industry, then there are technologies where the rare earth metals and other kinds of precious things can be squeezed out of that waste and used up in other places. So the technology is not the bigger barrier. The whole thing is that a start needs to be actually made from the volumes of agricultural waste that are getting generated in the country, then also from the large volumes of municipal solid waste that are there. To my mind, e-waste is a smaller problem. The question that you raised for the large bulk of inorganic waste, I see that as being something that needs to be handled by a combination of technologies, because it's very difficult to expect common people to actually be able to understand what kind of segregation they are required to do in a waste. I mean, I actually work in a company, and we have a place where everybody eats, and once you've eaten, there are three bins. One is a bin where you put your plates, and there are two bins where you segregate the waste that's there in your plate into two different piles. At the end of the day, you see that both the piles are the same. And this is a company that has a lot of awareness, and people just get mixed up because they don't understand what's expected of them. Going to a country as large as ours, it becomes a lot more complex. So I would say that the solutions do not need to be found much at the cultural level, they need to be found at the engineering level. And there are engineering solutions to these things. So that's my response to that. And I'm really glad that you asked me. Thank you.
Okay, thank you, sir, for sharing the answers so in depth. So we have done with the questions. Participants, any more questions? Please, you can unmute. We still have few more minutes. And actually, we have overshooted, but then still, it's good to have such an engaging session. And we have overshooted the time. So no questions.
I have one.
Yes, sir. Please, yeah.
So please, I would like to look at you as well.
No, actually, some fluctuation in the
Okay.
network I'm facing.
Okay, so
So
please go ahead.
with video call, it is not happening. So
Okay, sir,
I
please
off.
go ahead.
From the session, I could able to understand, or at my previous like some sessions, I could able to understand that technology is the prime solution for cope up with this waste management. But who
Yes.
will invest or who will start? Because public can be start as an entrepreneur in like couple of years when our government has pushed up for the entrepreneurship. But at the majority level or fast mode, who will start? Government or private organization or JVs or like that?
Sir, I think that the model that we have in the country is a model that has served us to a significant extent. What has happened is that when private industry was weak, the government was doing a lot of things that private industry was not ready to do. For example, most infrastructure in the country came into existence through the government doing it. Government built the roads, government built the railways, government built the hospitals, government built the schools, government built the telecommunication network. Then when the country started reached some level of maturity, some infrastructure was in place, private capital started stepping into that place. And now we have a lot of private capital doing what earlier the private players were not ready to do. So you can see that in education, you can see that in health, you can see that all kinds of sectors of public life. So I personally don't see that we need much of a very different model from this, but I do agree on certain things that fall into our realm of skepticism, and that is that the government needs to step up and propose something big for industry, because once it starts doing that, then things start picking up. The government let's take an example. The government started stepping into solar space and challenging industry to do certain big things. Now you have all kinds of solar panels springing up on rooftops in many parts of the country. People tapping into solar energy and pumping it into the state grids. At least I belong to Uttar Pradesh, and that's happening in a significant way in UP. I live in UP, and our office is also located in UP, the central office where I'm sitting right now. Other states are following in, and so things do pick up. So that is where I tend to agree that the government initiative becomes a significant thing for propping up private capital to do things. On the other hand, it appears that private capital is also looking for profitable investment. You have all kinds of venture capitalists in the country who are ready to invest, provided they get convinced that something is going to work out. To me, waste to energy technologies are the order of the day. It's just a matter of time and a matter of good, well thought out effort, and we should start changing things in our country. Because as I was trying to show that the scope for this thing is huge. The scope for these, because you have 99% of the waste lying around not being used or being used in ways that are extremely inefficient. And so a lot more can be done. Getting back to your question and winding it up, I think that the system is in place. What it needs is thrust, some thrust. Thank you.
Agree, sir. Actually, we are 5 people working for the clean water solution from 3-4 years, and then we came up this challenge, like waste related challenge, because waste lying here and there is contaminating clean water available in the village area or city area. You rightly said that engineering solution is the great way, and we will seek with the local administration as well that what the orders or what guidance they have and what kind of support they can do for the local control and safe disposal of these wastes.
If I may ask, Mr. Vishkama, where are you based?
I am based in Rajasthan. But it is border around 100 kilometers from Delhi.
Okay. So we at Quality Austria would love to associate with people like you who have these kind of interests. Let this meeting not be the end of our engagement. Let it be a beginning.
Okay, yes, sir. Actually, I am associated earlier also with Quality Austria, but maybe somehow I disconnected with this one. Currently, I am connected with 5R Earth related to the river cleaning campaign.
That's great. Yes, Saurabh.
I think so. We are done with the questions as well. So, if he has any more questions, we are good to wind up the session. I would like to thank all the participants for having their active participation and engagement during this webinar. And we really thank you for finding the time to attend this webinar. And before we close, big thank you to Hardeep sir for giving his expertise and answering the question in depth that would have definitely helped all the learners.
Thanks a lot, Saurabh, for organizing everything. And a big shout out to everybody who participated and especially to those who stayed with us till the end. So thanks a lot. Thank you very much.
Sir.
Thank you.
Thank you.
Thank you.
Thank you, everyone. Yeah.
Thank you. Thank you.
Thank you, sir. Thank you. It was
Thank you.
very insightful.
Bye-bye.